Welcome, Woodland Park High School students. You are embarking on one of the coolest scientific studies I think that there ever is, and that is the study of astronomy. Today, in our first video podcast, what we want to do is we want to learn about the size and the scale of the universe. Learn about some important key terms so that as we begin our discussion about what's in the sky, like the sky behind me, we will discover amazing things about the universe in which we live. And so that's where we want to start in the beginning of all this stuff that we're trying to learn is how big is the universe, what is out there, and also learn some key terms so that we all can kind of speak the same language. Scientists sometimes speak kind of weird language and they got all these weird terms. We want to make sure that you can kind of speak our language a little bit. So that's where we're going to start. So here we are. The preview video, okay? That's what we're talking about today. We're going to talk about the scale of the universe and some key terms to understand. Now, to understand astronomy, though, we need to learn a little bit about what? That's right, the Earth. You see, we live on this rocky thing called the Earth. Somewhere down here, you and I live. Woo. Okay? It's a spinning rock. Spinning, you know, it doesn't feel like it spins, but yeah, it's a spinning rock that seems very large to us humans. You know, I've been all over this Earth, not all over, but in lots of different places on this Earth, and it sure seems like a large place. But it actually is very small in terms of the scale of the universe. This little rock is a small little rock filled with some water and you and me, but it's a small thing. Seems insignificant. Now, one thing that we can see, and you're well aware, of course, is that spinning around the Earth is the moon. All right? It is the moon. It is called a satellite because it goes around and around it. We actually produce satellites, of course, right? Satellites that go around the Earth that work your cell phones and all kinds of different things. All right? But its surface is not the same as that of the Earth. It's different or unlike that of the Earth. Okay? There are also many planets, and you probably studied these in your middle school, elementary school. This, of course, is the famous Jupiter. I like a Jupiter. Did I spell it right? I think so. And, of course, there's other planets that we can look at. Okay? There are 7 other planets. You probably know them, memorize them: Mercury and Venus and Mars and Jupiter and Saturn and Neptune and Uranus. And I forget one. Well, Pluto's not a planet anymore. It's a planetoid. Yeah, I must have missed one. But, okay. There are other worlds with very different landscapes, different atmospheres. That's the stuff that's in the air, like we breathe, and environments. In fact, the only place that can sustain you and me is, well, that's the Earth. We can only survive on the Earth. We couldn't survive if we were on Jupiter. In fact, we'd sink because it's like all gas and stuff. All right. The other thing, and probably the most important and prominent feature, of course, in our solar system is the sun. Okay, you look outside on a day, and, of course, well, you see the sun. It's a huge ball of gas, of course. Compared to the Earth, it's 100 times the diameter, all right? So if this is the sun, okay, boom, from here to here, you know, the Earth might be about that big. Yeah, that's about it, that big. 300,000 times more massive. It's much, much heavier and much, much bigger than our little Earth, and it produces vast amounts of energy for our solar system. In fact, all the energy from our solar system essentially comes from the rays of the sun. Okay? On a hot day, if it's a hot day in Woodland Park, it never really is that hot, but on a hot day anywhere, the sun is giving us the energy that we need. Now, let's give a sense of scale. Now, how big are the planets with respect to each other? So which ones are big and which ones are small? Now, I've got a cool graphic here, but let's take a little tour. Take the tour. We're going to go on a field trip.
Wow, these planets seem so different when you look at them to scale.
Yeah, a lot of people really think that the Earth and Mars and Jupiter are all kind of like the same size, but if you look at the display behind us, you'll notice that they are in different sizes. You can see the Earth, the blue thing in the middle, and if you kind of span over to Saturn, you can see, oh my gosh, it's so much bigger. And you can see the moons of Saturn right there, and then Neptune, and the Earth is really very small. And actually, if you pan over here, you can see the sun, which is too big for the display. So it's very, very interesting. A lot of people do not know that.
Wow, that's very interesting.
Yes, very interesting.
That was a cool field trip.
Yeah, the Smithsonian Institute is such an amazing, amazing place. But you can also see the scale of the universe here on my graphic. Right here, number 1 would be Mercury, and then number 2 would be Venus, and number 3, that little dot right there, yeah, that would be the Earth. The Earth itself, okay, the Earth is tiny. Mars is even tinier. And then we have the big J, Jupiter, Saturn, they're about the same size. And then there's Neptune and Uranus. And wow, these guys are much bigger right here than these guys, aren't they? In fact, we kind of label these. These are called the inner planets. Inner planets. That says planets, if you can't tell. And these are the outer planets. Huh, that's easy, right? Sometimes these are also called the gas. These are all the gas ones. They're made of gas. All right. How far apart are they? Now, if we have our little diagram right here, here would be the sun. It looks kind of small, but of course it's quite large. And there would be Mercury, Venus, Earth right there, and then Mars. Okay, so you can kind of get it. This is drawn to scale, so this picture is like accurate. And then if we jump to our outer planets, okay, here would be Jupiter. Now, you can't really see because the Earth would be way in here. So all the inner planets that we saw on that last screen right here are all in this white circle that I've just drawn. There'd be Jupiter, and this would be Uranus right here, and then Neptune. Where'd Saturn go? I lost Saturn. Here's Saturn right here. There we go. So they're actually very far apart, aren't they? So it's pretty amazing to get that sense of scale of how big they are. Now, how far is the Earth from the sun? Well, it's not that critical to totally understand that. I mean, it is to some degree, but here's the Earth right here. Okay, but the distance from the sun to the Earth is called 1 astronomical unit, or 1 AU. And so we're trying to measure things out in space, and so we measure it using this funny unit called an astronomical unit, which is the distance from the sun to the Earth. Now, this picture is a little bit weird. It's not drawn to scale. The sun actually is much bigger. The Earth is too big in this scale, but it doesn't take up that much of the center of the solar system. This is just kind of a graphic artist's rendition. And then our solar system is a part of a galaxy. Now, a galaxy is a cloud of several 100 billion stars. Several hundred billion stars. I should just say, like, 200 to 300 billion stars. And this is a picture of the Milky Way, a rendition. No one's ever been outside the Milky Way to take a picture, but this is what it would look like had it been. This is what we call a spiral galaxy. And our solar system, which includes our sun and the Earth and Jupiter and everything, is somewhere out in one of the outer rings. So our sun orbits the center of the Milky Way. Now, the center of the Milky Way is a very bright thing there, and it rotates around. That's our solar system now, rotating around the center of the galaxy once every 240 million years. And the center has an immense cloud of dust, very bright dust because it's like stardust and it's reactions, and we'll learn about all that later. So we're a part of this thing called the Milky Way galaxy, which contains 200 to 300 billion stars. That's a lot. Oh, my word. Okay, now another thing we talk about when we start measuring very big distances is something called the light year. Now, light travels very, very fast, okay? It is the distance that light travels in 1 year. Now, when you turn on your light at your house, the light turns on, and instantaneously, the light turns on. That means the light travels from the light bulb all around the room immediately, right? Actually, no. It actually travels with a particular speed. It's so fast, though, when you're close, that it makes no difference, that the light, boom, comes right into your room, as it does in this kind of cool picture. It travels at 186,000 miles per second? Oh my gosh, that's fast. Well, why do we use a light year? Why do you use the concept of a light year, the light that travels for 1 year? Because the distances in the universe are very far. They're a long, long ways. So if you use this term called a light year, okay, and so when I say something is 1 light year away, it's actually 6 trillion miles away. And if it's 100 light years, it'd be 600 trillion miles, which is a number that's hard to wrap our mind around because it's so big. Okay? Now, interesting thing about our universe, if we expand out any more, which we're doing right now, we can find our Milky Way galaxy. Remember, that contains like 200 billion stars.